Today I want to do a small proof about circles. We know circles for quite a long time. We've worked with circles in analytical geometry and Euclidean geometry. So basically what I want to do is to prove that there is no small circle. There is a basic question. How small can you make a circle? How small can you make a circle? I am saying that there is no small circle. That is a nice statement, but how can we prove that? Now, we're going to prove that using proof by contradiction. Let's assume that there is a small circle. We'll take our initial circle starting from the initial point and then chopping down to this small circle that we assume it is existing. So we are assuming two things. We are assuming a large circle because, we want to prove the lower bound, okay, by contradiction. So let's assume that there is a small circle. There is a small circle with radius equals to t. And then we'll be taking this circle from a circle of radius equals to k. We're assuming that this is the largest bound circle. But we're not interested in the upper bound. We're only mainly interested in the small circle. How small can you make a circle? I want to prove that there is no small circle. So let's start. We're going to prove this using proof by contradiction. So assume there exists a small circle of radius equals to t from the large circle of radius equals to k, where t and k are the elements of the real numbers. Now t and k are the elements of real numbers. Now we're about to finish our proof. We know real numbers are not bounded. Assuming that we have this number line with numbers, it could be rational numbers, it could be integers, it could be anything. Integers are not bounded. The rational numbers, okay, for rational numbers, okay, they are not bounded. Natural numbers are bounded, but since t and k are our radius for these two circles, and the smallest circle with the radius of t t and k are the elements of real numbers, which implies also that t is the element of real number. Since the real numbers, by definition, the real numbers are not bounded, which also implies that our circle will not be bounded. This will be a contradiction because t are the elements of real numbers, which implies that also the smallest circle should not be bounded because it's the element of real numbers. Then we conclude by saying, okay, which is the contradiction? Since real numbers are not bounded and we initially assume okay, we didn't assume, and we know T and K are elements of the real numbers, and this completes our proof. So to explain what I was trying to do here, I assumed the lower bounded circle, not the lower bounded. I assumed that there exists a small circle. Let's assume that there exists a smaller circle with the radius of t. Now I want to prove using contradiction that that is not true, which implies that there could be a circle which is smaller than this one with, let's say, a radius of t minus m. M could be 1. We can say t minus 1. And this is a huge contradiction. So this will complete our proof, because our initial assumption, we said there exists a small circle with the radius of t. But now, what is t? T is the radius, and t are the elements of real numbers. Real numbers are not bounded. And this completes our proof. Thank you. There is a nice mathematical working of my proof. There is the smallest circle, but remember that if this is the smallest circle by our assumption, but we disprove this, that there could be other smallest circle. There could be, we said that the smallest circle has the radius of t, but there could be another smallest circle with the radius of t minus m, because real numbers are not only bounded to t. Real numbers could be bounded to t minus m. Real numbers could be t minus q, t minus d, t minus alpha. No, they keep on going to negative infinity and to positive infinity. And then this is a contradiction, and then we come to a conclusion that this is not true. Hence, circles are not bounded. There is no small circle, in fact. Even for the upper bound, for the upper circle, we can prove that there is no largest circle. There are infinitely many large circles, but there is no largest circle. Thank you.